Okay, so this session we are going to talking about what is gRPC. Then we're going to compare it with REST APIs, right? And then we see a sample code based on gRPC with. Okay. So now, anybody has any idea regarding what is called RPC? Or do you know the full form? Have you ever worked with RPCs before, or you heard about that? Okay. So RPC about is remote procedure call, and it was previously is used to call like a normal client side to Java side programming. Like there was a programming language or protocol was there named as Corba that was used, and it has the implementation in Java section also, which is used to from this client side. You basically call the server over a port, and it don't follow something like a remote procedure call. So it is written, no specific client or HTTP client was used. It is basically simply called a server side call by using a stub or a representation of the server side. So that was like what is RPC was there. We're going to let's first understand what is the REST. We mostly all have developed REST APIs, and in case of a REST API, we know what is the benefit of it, what is the problem it has. So let's just review what is the REST is. So for and foremost, REST is something that is we all have been used. It is very easy to use or implement APIs, right? And it is been widely used, and it is compatible with your browser, so you can using REST API you can write the JavaScript based client side protocol to call them. And it also use predefined convention like status code, using HTTP status code for success or failure. We can use Django and Flux for creating this REST out of the box for the API, right? Okay, and it's over HTTP 1.1. It basically communicate. Okay, so it's very easy to use. Anybody can write a REST API, right? And in REST, what we have is everything as a resource. You define a particular router to that particular resource. It's whatever framework you use, and then obviously you represent that particular request using different verbs like operations or actions that you can perform get post to, that we all know, right? Okay. Now, what are the problem with REST that we go to the gRPC? So where the gRPC has started? So it is like a open source framework that was developed by Google and other contributor like Square, and it was a kind of like developed, or is the first version was released in 2015, and obviously it doesn't work on HTTP 1.1. It basically works on HTTP 2.0, and it's basically create a language neutral protocol buffers or binary format of exchanging data. And it has like comparatively faster it can process. It has inbuilt auto load balancing enabled. It has been secure, right? So how this is different from REST? Okay, that's the framework that has been created. It's kind of like a universal RPC framework, and it can be supported in many languages. It support Go, Java, Objective C, C Sharp, and also it has support using other protocol like, okay, and it is particularly language neutral. So it basically have a certain of a representation with the help of protocol buffer. So normally we use with our REST API is XML, we can use JSON, we can use plain text. But for exchanging data, it basically use protocol buffers, and it mostly uses a binary format of data. So now let's compare with this REST. The main question going to come, why you going to be using gRPC? We already have REST APIs, we already have GraphQL for defining APIs. So why we are learning another protocol, another standard, another framework? So first we need to understand what are the problem with the REST. So when we get the data from JSON format uh, may have a schema. You can have like a JSON schema, but normally what you need to do as a development lifecycle, right? We have to check the types, whatever the data types has been sent across, and whether there is proper string, integer, etc. has been sent. Also, the data that has been sent is correct or not. Those manual validation we have to include, and also the client side of REST APIs is difficult to update when there is a change on the server side API. So normally when REST API, what we do, we basically use version in the path variable v1, API v2 or v3, and then we put the variable name. And now say for v1, we are moving to v2. So to keep backward compatibility, if I need to be working with that particular protocol, that particular version of API, I need to either create a new version of the client, and there is also no automatic way of generating the client code either, right? But we can generate using Swagger. We can first need to build Swagger and then we can generate, right? But it is not inbuilt into the REST specification. There is no standard way of generating or maintaining or updating this client. Everybody need to write their own client libraries, right? So for example, say my client is in TypeScript, right? And my server-side code is in Python. There is, I have to basically use a common standard like Swagger or OpenAPI definition, then generate the particular Swagger code to either TypeScript or Node, or maybe I need to convert that into .NET code. Okay. So there is I have to maintain the client side library. And the library, not only creation of the library, also implementation of the libraries. Because only just creating the POJOs and the contract operation is not enough. So I have to do those stuff, right? So that's are the some of the problem that we find with REST. Okay. And also it is difficult to create streaming. So now how gRPC may be involved out here. Okay. Oh. Now gRPC, what is support? It's by default support 2.0. It uses protocol buffer instead of JSON. It has a strict API contract. So API contract of it has to be developed first. So it is basically contract first development rather than code first development. So for protocol buffer, what you generally need to create, we need to create a poto file, and from the poto file we can easily build the code using different commands for different languages. So it has a built-in code generator. So I don't have to define this separate Swagger and use another third-party tool to generate the code for different languages. I can use the frameworks implementation for the language and I can easily implement that. And it support kind of a four kind of API patterns. So what are the four kinds of API patterns are there? So basically gRPC have a code generation, which is language agnostic, which is inbuilt. Okay. And it has strict context, so I don't have to do any kind of additional manual validation, right? And also another advantage of using protocol buffer, at this it exchange the messages in the binary format, is the decrease in message size. So for example, the message size that is representing say age, first name, last name in JSON format may take around 55 bytes, where in the protocol buffer in the binary format, it only takes 20 bytes. Obviously, what the benefit is that you can send out the more data by the this protocol buffer and the JSON. It basically half depending on the structure of data that you are handling. And it has four different way of writing the API using gRPC. What are the four different way of writing APIs? One is unary or the client to server. Then is server streaming, where client send a request to the server and server start to stream the data back to the client. Then time streaming, where the client basically send multiple records of data to the server and server then At the end, process and return the result back to the. Yeah. So first one is very simple, and then there is like bi-directional. Basically, client and server both start streaming the data as or when the input from the user is available or the server side results are available from here. Okay. Now it also has inbuilt load balancing. So if you are making a call, it may distribute the load between different nodes. And other benefit is when you are updating the contract, it does regenerate the code and automatically your client code get updated and as well as implemented. Okay. So basically, with the reduced amount of data that is we need to exchange, and we can support compressed format of data, so it can process more threads that are there. Because with the JSON, what happen is that you have to take more CPU incentive work on the client side to process the incoming data to the JSON data to the binary to the your objects, Python objects that you need to modify, right? But as the data that is coming from the binary is less CPU incentive, so on the client side it can faster process the data, and also so the server side you can returning less more amount of data with less amount of time by encoding the data into the Python objects to the format. So both cases you get CPU process improvement. So basically gRPC is much more faster than your normal REST API. So now the question comes how it is faster. That one point I already mentioned is the serialization and deserialization of the binary data with reduced size. And it supports load balancing. So obviously not one server is by default has been overloaded, and also it support streaming. So what is the streaming does? It basically helpful in more frequent data exchange between the client and server. So instead of waiting for the response to be get back, it can return the result back to the client in a much faster way. So for example, so client side and server side bidirectional. Say for example, you are generating some sort of uh, server side continuous stream of data based on user events that you are or clicks that have been counting, and on the server side you are calculating the overall aggregation of the user click or throughput per page basis, and you can show the engagement count, and engagement count can also be updated after a certain interval. So it can be both stream of data that is coming from the client and stream of data is going from the servers to the client. So that means they are not waiting on multiple requests, rather than they are streaming the data. That's why it can be much more faster for process such kind of a use cases. Okay. Now the question comes, what is exactly the protocol buffer? So what are the protocol buffer? So it's basically representation of data. Okay. So what are the different representation of data we have? As we know, we have JSON, we have XML, we have plain text, etc. So protocol buffer is basically a platform neutral and language neutral mechanism of serializing structured data, but smaller, faster, and much more simpler. Okay. What you need to do as a part of protocol buffer, you need to define your structure. Okay. So in the remote procedure call, what happened? You send a message, you get a message back, right? So here, when you are sending a message or a request and you're getting a response message, etc., so you define the structures of those messages and the operations that you can perform on them. Okay. And so you need to define your function or structure of your data once, and then you can easily generate the code in one of those 11 languages that is supported, or many other community supported language by inbuilt or community supported code generator, right? So that means you can use in any kind of well popular languages that are there. It may be Objective C, it may be C Sharp, it may be Java, it may be Go, it may be Ruby, it may be Python, etc. Okay. And also you can form a data stream that is either client side or server side streaming. Then after you define your protocol buffer, we generally define in a file name dot proto. And in this proto buffer, you then generate the code into your language of your choice. Okay. And then you can send and receive the code that are there. Okay. Now let us see some example. So the basic client and server example. So first and foremost, it's a very basic thing is photo. Okay. Here we are defining these protocols in two different files. One file contains the RPC or remote procedure calls, and another file is representing the what are the different types or messages we can exchange between the client and server. So first and foremost, you are using Proto Buffer version 3. You can define the packages just like a namespace, and within that you can define messages. So in the messages, what we are defining, we're defining the core object, that is the user, that is our domain object. Then you are mentioning its type, string, signed, unsigned, integer, etc. Okay. And you can also add whether this is a required, not required, etc. as well. And then you followed by the field name and the index position of that particular field. Then this is like core user object. Then we have two operation out here. One is create user, one is the get user. So here you have the create user request where you're passing all the three things: username, password, and email. And create user request return is basically an user. Then get user request where you are returning a user object which can be repeated, and the response is one single user object. Okay. Now when you have this, what you have to do, you have to convert this into your Python code. So for using Python or proto buffer, you need to install some of the standard libraries that is there. So how can we get started? So first and foremost, we need to install gRPC IO, that is the basic Python library that we need to install. So here we have the gRPC IO. We install this particular package. Okay. After gRPC IO, we have to install gRPC IO dash tools. Tools is basically help us to generate the source code generator from by reading the protocol files. Okay, and then we need to also need to install protocol buffer stream and user protocol based model. So we need to install protobuf. These are the more or less three basic libraries you have to install. Now, what you need to do, you need to create a folder. So here we create a folder, say services user. So user folder is created. Under user folders, this build process create lookup for protocol path under services or that particular location, and then the out directory is the destination directory, that is the gen py, and the protocol gRPC Python out directory is the same destination directory, and under services you have dot proto. So whatever protos are there, those are being used to declare this. Okay. Similarly, so let us see if we can, generate this or not. So let us go under the photos folder. Now let's run mini quad. Can be possible to create. Okay. Okay. Under demo to photos, then we have to save the message. Okay, Python etc. is not found. So can I is then we have VNB created. Okay. Let me try to do this using sorry, git bash. Okay. What do you have need to install? Oh, okay. And we need to install is gRPC tools, and then we need to install them. Before that, we need to install gRPC IO. Then we need to install gRPC IO dot. Okay. So all the three things are there. Now what we need to do is like to go cd photo, and then we like to generate the source code. So already there is build.sh is there. Let us run this. So let's see under here anything has been created or not. Okay, so here we can see the gRPCs are being created. So all this code that are there, the two protobuf files are there, they have been created out here. It is importing everything from protobuf and the other descriptor, etc. All these details are there. So that's how you can create. So your per gRPC files, the two files will be created. So based on your file name, user underscore pb2, inter underscore pb2 slash gRPC. So these are been created out here. Now how going to be using this on the server side? Okay. So we need to copy these files into the same path or folder location, and then we should be importing them. So after this generation, we just copy all of this and under server, let us try to paste it. So that has been done. So here we have to import it from gRPC and the types, because types is what we need to require. Okay, and then we need to be using the types or messages, and the gRPC the main methods. So if you again look back to what are the methods are there, it is RPC, how it is starting, create users, then the user types, you are getting create user request, get user request, and get user result. But here you are using stream. So it is like the second option, where the client side you are sending a request, on the server side you are sending a get response, right, in a stream format. So let's look into the server side code. So server side code, you are getting the service, the user service that has been generated out here, and you creating new user. Okay, here you are getting one request object as you are implementing from that. So this is the request object and the context object. So this request object is nothing but the create user. After that, it's just getting the metadata and printing out the metadata detail for debugging purposes. Then you are just simply user messages users, username, request.username, and user ID. You are just putting one. And then you are returning, calling this user messages, create user result. So that is the result object where you binding this user object. And get users, what you are doing, whatever request things are coming, you just yielding the same responses back to them. Okay, very simple. Here is no databases involved, but you can easily include any database or other things if you wanted to. Now we need to start the server, right? So what has been included is the gRPC main package has been included, and from the gRPC package, what happening? Server is created, which a thread pool of maximum 10 workers, and user service, add user service to server. So here you are adding the user service to the server objects. So if you have other protocol buffer files, so you can add those. Then server at insecure port. So this is just simply running on insecure port, which is running on the server. Then start. And then you have like a keyboard interrupt if you wanted to stop the server. That's a server side code. Whatever been generated, you can easily use that to do the request response, and you can add the database side or persistent storage side out here as well. And here you just simply adding server.py. Okay, so you can do that, or you can come one level, etc. Now how the client we're going to be working with? Maybe we can move this instead of here, because here also you require on the client side the same objects, right? So let us move them under user. Or maybe I can move them under this. Mhm. Alternatively, what I can do is instead of I can copy all of them in the same folder as we are doing it before. And also in the client, I can copy these two. Client wrapper has been used, so I can move the client wrapper inside. Okay. So now everything is being imported. So on the client side code, what I have to do, I have to create the user service. I'm going to need to call the user service, user stub, which we are calling, and it is coming from the local host 5051. So that's the IP address, right? And here, if you have the multiple servers, you can put the IP addresses there, and then you are sending the user request. Name similar to if you are getting the user being created, then after that you are calling the get user. Or here is just a sample where you have just sending the both users and the user responses. You just want to be printing this out. So let us run the servers. Okay. Here we see services. Then you have users. Then you have server. Then you can simply put Python. And here is the server name is server.py. Let's see if the server is started or not. So look like it started. Now let us open up another file. and let us call the client side of code. Here you have sample client. It has one error. Also, listen call last. Module not found. No module name found is gRPC. Though we have added that because here we have not enabled the virtual environment, so that's why it's not able to find it. Over. Now that is there. We're going to gRPC, go under users. Now we're going to be running the client. This is the sample client. So getting the both responses. We see the user being created. We see the other two user result being coming back. Now let's look into the other thing. So there is how the different way the clients have been created. One is basically you just based on the protocol buffer. You have the client wrapper. What is the client wrapper is having? It having one class, which is basically creating the insecure channel from the host and post. That is the including gRPC, and then from the channel when the channel is ready, it basically initializing the channel. Then you are getting the stub name, the attributes, etc. You are getting, and the timeout you are setting. That one. Then it is basically wrapping a call. So get attribute is the method it is calling with a timeout, argument 2, argument 1, and this value. And there is any error, it basically printing that out and raising that particular error. The sample client demo, if you wanted to utilize directly, okay, you just come out here, you call the run method, and here you are getting that insecure client channel. And if you have an error, you can print it out. Otherwise, you just use the simple stuff to create that, and then you are making a call same way as before. And then you have the timeout that is mentioned out here. How many time you're going to be waiting on that particular response. So if you're getting a timeout, that will also be printed out. Okay. Now here you have the timeout dot timeout dot py. So in the last phase, what happened? You are expecting a particular time, and that time has been exceeded. So you are expecting the result to be coming back within a 0.00001 second, millisecond, but it is taking more time. So that's a error that you are seeing out here. Okay. So using this, we have seen that we can call this and say how we're going to be using these things over an API, be it Flux. Here is the example with Flux, or you can use first AI, right? But in the first API, what you have is basically you have kind of a JSON format that is there. So here you have Flux and you have your other microservices in those formats, right? Mhm. Creating the users, app config user, you are defining the service client just like before of the normal console client, and you are getting the request and getting the response, and you are whatever the request and response object you are getting, you are returning them back. Okay, so that's how you can integrate first API Flux or Django with gRPC also. So any question on this? Okay. If there is no question, I will request you to guys to look into other things related to gRPC. One is the authentication, then comes logging and metrics collection and error handling. Any question? Shantanu, Priyankush, Sarita, Vikas, Bhavani, Dipankar, or
No, no, Suresh.
Saurish, do you have any reference link for this so that we can be go through that, and if we have any query or how we can implement this, we can do the practice over it.
yeah, I will build a presentation. I can share that with you.
Okay. If you have any reference URL, then we can be go through that, and we'll
Yeah.
be glad to
So for
explain.
reference URL, what you guys can go right is grpc.io. So grbc.io has the detail like how to introduce into the gRPC, right? Here you can see the Python quick start,
Yes.
how you can install different tools, basic example, etc. Yeah, they give us Git service, how to update that, how to run it, etc. That's one. Then you can go into basic tutorials that are there. Go to language, see how you can do that services. This is basically about how to define the schemas on the proto buffer, right? What are the data types are that is there. That's a one introduction. And you can easily go through the docs. In the docs, you have guides. Here you have the authentication. How can you input authentication with gRPC? You have error handling. How can you do the error handling over that? How can you provide richer error methods apart from what is the default status code it's returning for different things? Then you have how can you improve the performance? So those are the basic things that are given there, right? And the language specific there. Wave is gRPC wave. If you wanted to use a simple working example, you can look into that. How can you do that. We have like a sample base file. You can do this if you need to in a basic tutorial. So that is the initial basic codes are there. Then you can also look into the showcase, how it is being used elsewhere, right? And you're going to find some of the books that you can have look into is the gRPC in action, gRPC and protocol buffer, a simplified service mesh with gRPC. The videos and slides are available over different talks. Right. And gRPC conference 2020 presentation videos, etc. is a good starting point for you guys. So this is just another mechanism of creating APIs apart from GraphQL or REST that we are aware of. It has a certain benefit of them that we have discussed. Okay, so if no more questions, then we can close the session for now. Thank you, guys.
Thank you.
Thank you.
Thank you.